All right, mass percent composition. There's this long formula right here. Guys, really, sometimes these books make things so hard. I don't even understand why they do it. Okay, I'm going to kind of explain in my own words. Let's say I give you carbon monoxide, okay? And if I were to ask you, what percent by mass is the carbon and what percent by mass is the oxygen? Most people would say 50-50, correct? 50% of it is carbon and 50% of it is oxygen. That is the best wrong answer, okay? If you said 50-50, good, you're thinking. This is percent by the number of atoms. Sure, half of your molecule, half of your atoms is carbon, the other half is oxygen, but it's not by mass, right? Carbon weighs 12.01, oxygen weighs 16.00. Based on the mass of this, a little bit more of it is the oxygen, okay? Because it's based off the mass, not based on the number of molecules, okay? So how do you actually figure out the percentages? Well, it's like any percent, all right? It's the part over the whole times 100, okay? So what's the part? The part is these. It's the mass of each individual atom. What's the whole? It's the mass of the whole entire thing. Okay, well, the mass of the whole entire thing is 28.01, all right? Well, how did I get that? Well, 12.01 plus 16, okay? So if you take 12.01, the part, divide it by 28.01 times 100, and then if you take 16.00 divided by 28.01 and multiply that by 100, right? You will get the mass percentage of each of those atoms, okay, in the molecule. All right, so if you take 12.01, divide it by your 28.01, and then multiply by 100, you get 42.9%. And then if you do the same thing for the 16, you'll get 57.1%. So it's not 50-50, it's 42.9 to 47.1. Okay, and that's what's meant by mass percent. So if you read this, you might be thinking, I just did that. This whole thing is what I just did down here. Makes more sense if you just understand it. I mean, here, N times the molar mass of the element divided by the molar mass of the compound. I mean, seriously, come on. There's a lot easier ways to explain things. So hopefully, I'm hoping what I did made sense. Otherwise, I guess I'm in the same category. You do realize I'm trying to make a joke here and trying to make this interesting. Okay, so there you go. That's mass percent. Okay, so here they're basically just doing the exact problems I just did. Right. So in H2O2, the mass percentage. Well, you get the mass of the whole entire thing. Right. The mass of the whole thing is 34.016. Notice that is the denominator in all these cases because this is the whole. Now you want the mass percent of hydrogen. Well, I have two of them. So it's 1.01 plus 1.01, you get 2.02. They actually they go further out in their sig figs. It doesn't really matter what number you use. Okay, but there's two of them, so it's 2 times that divided by this to get 5.9, and then they take 16 times it by 2, that's 32 divided by 34, you get about 94%. Okay, so that's exactly what we just did. So here's some sample problems, all right? Lithium carbonate was the first mood stabilizing drug. I don't know if you guys heard of lithium as a mood stabilizing drug. Well, this was the compound, lithium carbonate. Okay, it was approved by the FDA, the treatment of mania, manic depressive illness, and bipolar disorders. Calculate the percent composition by mass of calculate the percent composition by mass of lithium carbonate. That means figure out the percent of lithium, figure out the percent of carbon, and figure out the percent of oxygen. Why don't you guys do it, and I will scroll through the slides once you're back. Welcome back. If you didn't, that was kind of quick on my part, but hit it on pause and we'll go through it. All right, here we go. So they first determined the mass of lithium carbonate. All right, lithium weighs 6.94, carbon weighs 12.01, oxygen 16. 2 times 6, because it's 2 lithium, so it's this number times 2, this number times 1, so 12.01, this number times 3, and you get a total mass of 73.89 grams per mole. Remember, anytime you see AMU, think of it as grams per mole. Okay, so 2, and you can do it, and these are the numbers. All right, does that make sense? If it does, great. If it doesn't, we'll do problems in class and you can ask questions. All right, we are going to actually stop there for this slide because 5.4 is going to take a lot more time. So I want to have a fresh slide for that. So I will see you back on the next video for 5.4.